Hey guys, today we'll be going over the H-bridge circuit. Before we go into the circuit itself, it's important to know what the circuit does and its applications. So essentially the circuit is used to change the direction of current on the load, and this is useful when you have something like a motor and you want to be able to control the direction the motor spins. So now that you know about the uses of the circuit, let's dive into the specifics of how the circuit works. So if we take a look at this circuit, it's pretty simple. There's two PNP transistors and two NPN transistors, and we can basically control these transistors using these two inputs, right? This A input, I have it called here, and this B input. And we can basically manipulate these inputs by either setting them high or low to control the direction of this motor in the middle, alright? So let's go through what that would look like. So we'll have two states that these inputs can be, right? We'll have two inputs. These can each be two states. So input A can be high and input B can be low. So if we do this state, then when we turn on input A, this transistor will be on and this transistor will turn off. And when we put input B to low, this transistor will be on, this transistor will be off. So basically these transistors act like switches. So whenever these switches are off, just imagine like an open switch, and whenever they're on, just imagine like a closed switch. So if you imagine these are open and these are closed, the current now has to travel like this through this transistor, then through the load, through the other transistor, through the ground, right? So if you imagine in this scenario, we have the current traveling like this direction, this way through the motor. Alright, now let's go through the other scenarios. So let us say we have a scenario where the input is low and this input A is low and input B is high. So when input A is low, this transistor here turns on and this one turns off. And then when input B is high, this transistor here turns off and this one turns on, right? So if again, just imagine these are closed switches and these are open switches, the current then has to travel like this, through this transistor, through this load, out through this transistor, and out to ground, right? So if you imagine, in this case, you see the current is now traveling from left to right, where in the other case, it was turning from right to left. So by using these two inputs, we can either have a 0, 1 state, where the input A is 0 and input B is 1, and 1, 0 state, where input A is 1 and input B is 0, but in these two states, we can essentially control the direction of current going through the motor. Now, let's say we have a state where A is either 0, 0 or 1, 1. So in this event, we want to make sure that our circuit doesn't short circuit, right? We never want current traveling just through these transistors, right? Otherwise, the current will be huge and it will blow up those transistors. So basically, in this setup, if A and B are both low, these transistors both turn on and these transistors turn off. So basically what this means is that current can't travel through this motor. So, and no current can travel through this circuit at all. So we're protecting our motor and our transistors. So now let's say in the other state where both our inputs are high, right? We're putting a voltage through both our inputs. If that ever happens, then these two transistors turn off and these bottom two NPN transistors turn on. But in this case, there's also no way for the current to travel through this motor or through this transistor. So basically, we've essentially created a circuit where we can use these inputs to control the direction going through the motor, direction of current going through the motor, and have also successfully protected our motor in any sort of catastrophic event where we accidentally put these inputs both to high. Alright, I hope you guys enjoyed the video, and that basically covers the very basics of H-bridge circuits and its uses for motor control.